Okay, so this is a quick walkthrough of the RD3D version 1.0 board, which I didn't realise there's actually an R2C2 as well. Having looked through the RepRap wiki. Alright, so we have 6 steppers. 1, 2, 3, 4, 5, 6. The Arduino Duet or a Mega 2560 goes around here, and got the ICSP, the SPI connector there. Power in, dual power in, 24 volts. Fuse 1, and that's routed directly to that one, so that's an isolated set there, and second fuse is on here. We also have 6 separate inductors for the motor. There's the 100 microfarad capacitors, so 1, 2, 3, 4, 5, 6. Tracks are completely, I mean, these parts here, because they're through hole, they completely cut off the tracks there, so it's been really challenging to get the routing. Thermistors here, so you've got T0, T1, T2, just like in ramps. SPI header with 2 chip select here, micro SD, buffer for the SPI on here, just on the outputs from the Arduino to the inputs to their chips, etc. come in, and those are fine, those are 5 volt tolerant, I think, but this is basically so you can do 3.3 volt and 5 volt. Another buffer chip here for the MOSFET, so you got 1, 2, 3, 4. This one's the big one, you get your separate power supply one. Then there's 3 here, and another fan here which can do up to about 3.5 amps, I think, on that, so quite big thing. These can basically take 60 watts no problem on 12 volt and 120 on the thing. You just got to watch the current loading on here. So 1, 2, 3, 4 big ones and a small one there. That's for fans, really. Now, the here we've got. Let's do a zoom in, zoom. 4 of these steppers are set up to do SPI. So using TMC 2130 silent step sticks. So a jump across there, 1, 2, 3, 4. That gives you clock, MOSI, meso, and chip select. Or alternatively, you can use it for A4988 compatible, and just I describe in the wiki how to do it, but to get the 2 compatibility, low goes across there, high goes across there for this for MS3, MS2 standard is in ramps, and MS1 is standard in ramps. But you have to join that because it's on the wiki. So there's 4 of those, 1, 2, 3, 4, and then those last 2, which just got too complicated to try and put the things on there. So I just left those. So I was saying, routing across here is just it's ridiculous. Trying to get the SPI on there, so I just didn't bother. Expansion header. That will be. The kind of thing is I2C there, SPI on here, and then there's 6 GPIOs, so you could use that for extra stepper boards, SPI based. You can get up to, I think it's 3, because you can use a dual pair enable and chip select on those, so there's 3 pairs of those, or you can get 2. You'll be able to use it for 2 A4988 or A498 compatible drivers. 3 pins, step deer enable, there's 2 pairs of those. The I2C there is just in case you want to put Digipot VREF conversions on there. I2C UART up there. This one has 2 extra ADCs, so you can use one of those for a Z probe. David Crockett's DC42 has a very good infrared sensor, and this one will be able to use for filament width detection. This pin would be for programming shared between either the filament runout or reprogramming the Z probe, uploading the firmware to it. The power plane on this has been hell to do. Let me do a flood fill and highlight there's the 24 volt 24 volt. Oh, by the way, it's dual 24 or 12 volt, and there's also a power regulator here converting down to 8 volts to supply the Arduino. So that's all on board, and that can take up to 30 volt, I think. So that shows you the 24 volt plane there, and it comes all the way down here, so it steps down. Bear in mind this one's isolated, completely separate, so it's not connected to this one. So you can do, you could do heated bed at 24 volt and this one at 12 or whatever you want. So this is in 1 ounce copper. This is a 12 amp power lane coming up here, splits here down to 9 amp and then 6, and then finally to this one. So as long as you theoretically you could get 3 amps to each of these, but it would be really you'll be pushing your luck. We'll see how it goes. Your forced air cooling flowing across the entire thing would be absolutely essential to do that. Likewise here. Now this one comes from there whilst it's still up at the 10 amp 12 amp thing, so bridging across there on that. Let's zoom in there. There we go. So bridging across from there to there onto a connection to that thing. It's on the other side as well, so you can see that's connected there as well. I did that so they get plenty of power, plenty of current to the things. This steps down to a 6 amp rail here, jumps across and bridges to that one, and then down to a 3 amp, finally to a 3 amp, and we're getting there. And that's to make sure that there's enough space around here to get a ground plane underneath. So at ground, yeah, okay. So you think the power planes are out of 2. The power planes are real mess on this, but there's not a lot you can do about it. So yeah, so you can see the 24 volts still highlighted there, but getting this in has been really challenging. For example, around here, the power ground comes in from these across to these 4 wires thing, and this one here, 4 wires there, then flips over to that layer here onto those 4, comes down to these 3, and then goes across to here, and then finally goes to that pin. It's been weeks of doing this to get it right, but it's down to the fact that this channel here totally isolates things. You can't get pins round, so I've had to put things come round this way. 5 volt power goes to get to the. Let me just take that back off. File, open recent. Dunk. Okay, right, there we go. So 1. So 5 volt comes from up in that top right corner from the Arduino or the Duo, goes down the right hand edge, and then goes to the 3.3 volt regulator to supply 3 volt power, guaranteed 3.3 volt power with enough current. Because remember, the Arduino can only supply 150 milliamp, so you can't rely on that, or less. So you can't rely on that at all. So I've had to bring in the 5 volt power, kind of step it down to 3.3 volt thing, and actually supply it to the buffer as well. I really should put that power onto that 3.3 volt power onto there, not use the 3.3 volt rail from here. Yeah. Think about that. Think about that once more. That might well be wrong. That might be wrong. So as well as going there, it goes around the outside and comes into down into that buffer chip for the MOSFETs. That's very important, that the MOSFETs receive